Howard Meeks, St. Mary's Correctional Center here. Today we're going to take a look at some fundamentals heading towards the new task test is dealing with some trigonometry. So I want to work towards trigonometric ratios. So before I do anything with my students, I want to make sure that I don't like to assume. So we're going to begin with looking at ratios, developing into proportions, and then looking at the basics of how that's developed into geometry by looking at similar figures. And then after this short video is done, then you'll be able to go to the help desk and click on my video on trigonometry, and when your students have these concepts down well, they'll be ready to move on and tackle the basic trigonometric ratios that you might encounter on the new task test. Okay, what is this?
Fraction.
And this is where I like to tell my students no. Or their other favorite answer is when I go yes. And what do I mean by that? Well, most students are going to say, yeah, coach, that's a fraction. Well, what's this?
A decimal.
And I'm going to say my favorite answer, no. Yes. What do I mean by that? Well, because what is this now?
A decimal.
Was it?
No. That's a
Period. And now what is it?
Period.
No. It's an eyeball. In other words, what context am I using this in? Just like what context am I using this in? Is it a fraction? Of course, it's a fraction when I'm describing something that's less than a whole. But what happens when I'm not? And we can use it as a ratio. And the technical term is, for a ratio it's the comparison of two numbers using division. And if you look at a fraction bar, we know that would be 2 divided by 5. So, Coach, now that you give me a technical term, what do you mean? What's a ratio? Well, what I'm telling my age a little bit, one of my favorite commercials, I remember when I was a kid, I guess I liked peanut butter, was 3 out of 4 mothers, choosing mothers, choose Jif. Okay? 3 out of 4. Well, Coach, what do you mean that's not a fraction? Well, I'm not going to cut the mothers up into something less than a whole. That might not work too well. So I'm saying out of the whole group of 4, that 3 of those mothers chose Jif. So in other words, I'm comparing numbers using division. Another way that you'll see ratios written, 3 to 4, or you'll see it written 3 to 4. Again, just using it to compare. Maybe another example, in my class, what's the number of students that have red hair? And in my class currently, 1 out of my 20 students has red hair, or 1 to 20. Another way I can write it would be 1 to 20. So when I use the term ratio, I'm just looking at comparing some things. Maybe number of boys to girls in the class, or whatever the word problem might be. Okay, so that's what a ratio is. So my question is, are these two ratios, 1 out of 3 and 3 out of 9, the same?
No.
And I'm going to say no, or my other favorite answer is yes. What do I mean? Well, I have one student over here, and right now I own a dealership of trucks, and I get a shipment of 3 come in. And Robert's been so good helping out, so I decide, you know what, I'm going to give him one of those brand new trucks. Okay? So he gets 1 out of 3. And the next week, I get a big shipment coming in. And when that large shipment comes in, I have 9 trucks. And, well, even though Robert's nice, you know, Gary's a whole lot nicer, so I decided to give him 3 of those brand new trucks. And so, are these the same? And almost anybody say, no. 1 truck is less than 3. But when we're talking about ratios, whether or not they reduce to the same amount. So if this doesn't reduce anymore, going back to your fraction skills, being able to reduce, this would reduce to 1/3, or would simplify to the same. Okay, and anytime that you have ratios that simplify to the same, we can say they're equal. Okay, and the term for that is proportion. A proportion is when 2 ratios that are equal. And as you can see, the numbers aren't the same, but these would reduce to the same, and we would consider them proportional. Okay, so I'm going to move on. How can students tell whether or not 2 ratios are proportional? And there's a few different ways to do that. The first way I like to show my students is a little method I call cross multiplication. And you'll hear me say where I start is where I finish. In other words, I'll start here and cross multiply. 4 times 6 is 24. And you'll hear me always say to my students, where I start is where I finish. So I started on top here, and so I need to finish and put my answer in the same side. And I can show you there's a little skill when you're comparing the size of fractions. This really helps out on. Okay, and 20, I'm sorry, times 2 is 40. So where I started, I put my answer in that same side. And is 24 equal to 40? And the answer is no. So these would not be, these ratios are not proportional. They're not the same. Okay, we'll work another problem. 4 times 12, 48. 16 times 3 is 48, and in this case they are the same, so 4/3 is proportional, or the same as 6/12. Okay, alright, so I'll sit there and work another problem and just have you let your students take a look and see if they can determine if this is proportional. Again, where I start, where I finish. 12 times 4, 48. 3 24s, 72. And you would say, no, these 2 fractions are not proportional. Okay? Well, Coach, you mentioned a minute ago there's a couple ways that you can check and see if ratios are proportional. And as you saw me work, you can always cross multiply. That way always works, especially when you get into some fractions that don't come out exactly equal. In other words, they might come in the decimals. But at times you can look at a problem and see, did they grow or shrink the same? In other words, where I began, did it expand or maybe reduce? What do I mean? All right, let's look at 4/3. Is it proportional to 8 times 6? And one of you might say, you know what? 4 times 2, or 4 doubled, is 8. And hey, Coach, 3 times 2, or 3 doubled, is 6. And so since the top and the bottom grew the same, then yes, I could say that they are proportional. 3. All right, now we're going to go on and work a few more problems dealing with ratios and proportions. We notice the instruction says solve each proportion. Definition of proportion means then that I know that these ratios are equal, or they must simplify the same. So that's the first key. Since I know they're proportional, the instructions say that I know I can set them equal to each other. They must be equal. Another little key is, I tell my students, we can only solve if there's only one unknown. I must know 3 bits of information. If you notice, I have 3 of the numbers, and I'm only solving for one unknown or one variable. Okay? And when it's set up this way, when I have a problem in that way, then I'm able to solve for it. All right, let's go back to the skill I said. Let's cross multiply. 10 times 4 is 40. And 8 times k is, and algebraically, we can write it as H as 8K. Now I will show you, explain this a couple different ways. One, that those of you that are a little more advanced in algebra will realize this one-step solution, or the one step that we're doing to finish solving the problem, is easy. Some of you that are a little bit greener in your algebra, whatever, I'll still show you a little way to remember, a little shortcut, I would say, or a little tip, maybe more appropriately, to help you work these problems out when you run into them. Okay, so since I tell my students I have a variable, and what am I doing to it? We're multiplying, and algebra is the land of opposites, so the opposite of multiplying, I would divide by 8, and that would leave my k. And what I do to one side, I must do to the other, because it's equals or keep the scales of justice. So 40 divided by 8 is 5. And so my answer here for k would equal 5. All right, moving on. Again, I'm going to cross multiply. M times 3, I'll rewrite as 3 times m. In algebra, they like you to put the coefficient in front of your variable. And 10 times 10, when I cross multiply, is 100. Because it's proportional, I know it's equal. Again, solving algebraically, the opposite of multiply is divide. And what I do to one side, I'll do to the other. And so m would equal 33 1/3. In other words, Coach, it did come out nice and pretty. And remember, I said that sometimes it could be a decimal, and this would be 33.3 repeating or whatever. Of course, I just changed it to 1/3. Okay. Let's take a look. Okay, and another problem. And remember, I said sometimes you can see, well, Coach, you said solve the proportion, so I know that these have to be equal. And 3 times 2 is 6, so 8 times 2 is 16. Would that be appropriate? Absolutely. Again, I said that there's sometimes more than one way to solve it. And if you can recognize that skill, will it always be that simple to see? No. And when it's not, remember, you can always cross multiply. 6 times 8, 48. 3 times a is 3a. And using my algebra, the opposite of multiply is divide. I'll do it to both sides. And you'll see, I'll still see that a is equal 16. So, again, sometimes you can use that common sense. And why would I do that? It will save you time on the test. Okay? And we all know when you're taking tests that are timed, anytime you can save a few seconds on one problem, that will give you maybe a little bit more time to scratch out and find an answer on down the road on a different type of problem. Okay, Coach, you talked about that's the way it always works, but sometimes that there's a shortcut or a tip that you had for setting up. What I tell my students, if you notice that you always have two numbers across from each other, and then you always have a number that's across from the variable. And the little tip I always teach my students is you're going to multiply the two numbers that are across from each other. 12 times 2 is 24. And then you'll divide by the number that's attached to the variable, where I would divide by 10. And in this case, we would get 2.4. And remember, I said you're not always going to get one that comes out nice and even as a whole number. Sometimes you will get a decimal. Okay? Over here then, what am I going to multiply? By 12 times 10, which is 120. And then I'm going to divide by the 2, which equals 60. Well, Coach, is that any different what we were doing? No, I'll go ahead and show you. When I told you to cross multiply, 12 times 10 is 120. V times 2 would be 2 times V. And using algebra, we divide both sides by 2, and we're still going to get 60. But for students that sometimes get a little bit confused with the algebra or not sure, this is a nice little tip. The two numbers across from each other, you're going to multiply, and the one that's stuck with the variable is what you're going to divide by. A nice little shortcut, nice little tip to keep for those that are really wanting to speed up in the test. And it seems to help my students move along. All right, now would be a good time for you to take a break and work on ratio and proportions with your students. And as you see, when you're ready to move on, we'll start again, and we're going to show how using the skill of ratio and proportion ties into geometry, and we normally first find it when we talk. All right, welcome back. Hopefully now you've had some time to let your students show you that they fully comprehend ratios and the concept of proportion, and work solving a few problems like that. And as I mentioned before, you had a chance to take a break. We picked this skill up in geometry. In the first place you'll see that is with similar figures. Well, Coach, what do you mean, what's a similar figure? And as you can see by my definition, a similar figure is two polygons or shapes with straight edges. So you're looking at triangles, squares, rectangles, pentagons, and whatnot. And two polygons that have all congruent angles. What do I mean by congruent? It means they're the same measure. Okay? Every angle here has the same measure in the same place. In other words, if this was a 90, and this appears to be a 90, then in that same corner would be a 90. If this was a 30, then that would be a 30, and if this was a 60, then that would be a 60. But these aren't marked, but looking at the visual eye test, they appear to be similar, and since they told me they're similar, then I would know that all these angles would be the same. Okay? Coach, what's congruent? Well, technical term, and we don't want to get too technical, congruent means equal. Why didn't I say equal? Because that 90 or that angle might be the same measure as that angle, but they're not in the same place. And geometry is about Earth's measures. We're looking at things in space. So that angle, although it measures 90 and this one measures 90, and they have equal measures, they're not in the same place. So when you see the word congruent, that's all it's referring to. Don't let it get you caught up. It means equal. Those aren't the exact two angles. One's over here, one's over there, but they measure the same. So taking a look, two polygons with congruent angles. In other words, you know, this corner would be the same as that one, the top would be the same as the top, and the right would measure the same right, and the sides are proportional. Again, after covering, what does that mean? Well, these aren't the same length, but this either shrinks, all right, that would shrink, this side would shrink the same as the bottom would shrink, and this right side would shrink down the same amount, okay? And I would be able to set problems up and show that they're proportional. In other words, the ratios are the same. So going into it, we look here, and I'll take a second here. Some of my problems I take from CUDA software, and they have a lot of free worksheets in geometry, pre-algebra, and algebra that you can go online. CUDA software, all one word.com. Okay, and you can also, as an instructor, purchase their software and have many more options. But to get you wanting to look at their features, they do offer a large amount of free programs, or I'm sorry, free worksheets. And the nice thing that I like about them, that I printed them off and can use some of them, is that if you go on down, when you print it off, they will have the answers. So you'll have an answer key for the instructors, and it's just something simple and ready-made. So I want to give them a little heads up, because I do like to use that as a resource and take this time to share that with you as an instructor. Okay, similar figures. Each pair of figures is similar. What does that mean? And that's what you got to make sure you let your students know. Right away, I know that they're what? The angles are measured the same, and the sides must be proportional. Okay? Without that, I wouldn't be able to solve it. Remember, I also need to have 3 knowns and 1 unknown. And you look, I have the numbers on 2 sides, and on the similar sides I have 1 and only 1 unknown. And now here's the point where I ask my students, does it matter how you set it up? And of course my favorite response is no. If you don't like that, yes. And so, not to confuse you, we'll set this up a couple different ways. I want you to make sure that you use good logic. Okay? What do I mean by that? Well, I'm going to set up as a proportion, which means what? 2 ratios or 2 fractions are going to be equal. Okay? And so let's set it up. I'm going to say that the left side, 12. And I'm going to compare it to the bottom side of my big one, 20. Okay? And so now you see I've made my fraction. And I'm going to compare that to the left side of the small, or 3, as the bottom is to the little one, or x. Okay? Well, I said, does it matter? And I went, no. Well, what do you mean by that? So let me show you. What if I said 12, or the left side of the big, and I want to compare that to 3, the left side of the little. Okay? And then I'm going to say is to 20, the bottom of the big, as x is, or the bottom of the little. Okay? Did that make sense? Did I use good logic? Yes. Well, Coach, you set them up different, but if we take a look, cross multiply, I'm going to have 12 times x, or 12x. And over here, I'm going to have 3 times 20, which is 60. Over here, what if I do it the other way, where I just say the two numbers together, I'm going to multiply is 60, and then I'm going to divide by 12. And I would say x is 5. Well, if I did the algebra here, divide both sides by 12, I'm going to say x is 5. So you see, either way that I set the problems up, we get the same result. Okay? So it doesn't matter where you begin, as long as you make logic. Where do I get in trouble? What happens if I say the left side is to the bottom, and then I went over here and I like the x on top, and I say the bottom is to the left side, and I flipped it. That's where your logic is off, and so you're going to have your problem set up wrong. Be very careful when you do it. Okay? Let's take a look, and I'm going to have a student go ahead and set one up. And so we're going to have a proportion. We're going to compare a couple things. And how do you want to set this up?
X is to 9, as 1 is to 3.
He says x is to 9 as 1 is to 3. Let's check his logic. Okay? Left, the little is to the top or left side of the big, and the right side of the little is to the right side of the big. And is that good logic? Yes. What if he had said 1 is to 9? Does he like that? And he wanted the x on top and said it as x is to 3. And let's look at the logic there. We would have the right of the little to the top of the big, and we would say, no, we're not comparing the same spots. So that's an example of what I mean, be careful. And as you can hear, he did a nice job of setting it up and using appropriate logic. So now you've got a couple different ways we can solve it. If you like to see it algebraically, we can say x times 3, or 3x, equals 1 times 9 is 9. Or if you like my tip, you can say my two numbers is 9 times 1 divided by 3, and x is 3. And if we solve it algebraically, we're going to come down and end up with the exact same 3. Divide both sides by 3, and 9 divided by 3, again, is 3. So either way, you're going to come up with the same result. Okay? And one last problem, just so I can show you. Again, sometimes you can see the common sense or a little bit quicker way to do it on a test. And here's an example. I know this is going to be proportional, but wait a minute, Coach. I noticed that my right side, okay, got 4 times smaller. 16 divided by 4 was 4. So hey, since I knew that it was proportional, or similar, so I know it's proportional, 8 divided by 4, and I could say is 2. And if you wanted to set this up and say 4 is to 16, as x is to 8, if your students would solve that out, you're going to find the exact same situation, that x equals 2. Okay? And 8 times 4 is 32, divided by 16, and 2. So again, sometimes you're going to see how it shrank or grew and be able to jump right to it and use that, I call it the common sense logic, and it does work. You just need to understand why it works. Okay? Hopefully this has been a nice short video for you to work with your students in ratio and proportion and taking on into basic geometry, finding the sides, the unknown side or missing side of a similar figure. Once your students have mastered these skills, again, look up my video on trigonometry, and we'll show how the concept of ratio and proportion works with trigonometric ratios. Again, Howard Meeks, St. Mary's Correction Center. Anytime you have a question or whatever, feel free to look up my information here in the credits and just contact me for help. Thank you.